Welcome to The Explainer. So, what could a viral video and the money in your savings account possibly have in common? Well, the answer is this really powerful mathematical idea, the exponential function. And today, we're going to dig in and unlock its secrets.
You know how it is, right? One day you see a cool video with a few hundred views, and the next day, it is absolutely everywhere. That isn't just random luck. There is a powerful mathematical engine driving that explosion, and we are going to peek behind the curtain.
See, the real secret here is that some things don't grow by just adding a little bit at a time. Nope, they multiply. Every single step gets bigger and bigger than the last one, and it creates this incredible snowball effect. And the tool we use to talk about this kind of growth? That's the exponential function.
All right, so here's our game plan. First, we'll get the official definition down. Then, we'll get into the huge difference between adding and multiplying. After that, we are going to decode the formula that makes it all tick, see what this growth actually looks like on a graph, and, most importantly, we'll talk about why any of this matters in the real world.
Okay, first things first. To really get a handle on exponential growth, we need to start with a solid definition. So let's just get that on the table.
I know, that looks like a lot of math jargon. But forget all that for a second and just look at the very last part. Multiplied by a constant factor. That phrase right there? That's the secret ingredient. You're not adding, you're multiplying. And believe me, that changes everything.
And yeah, that one tiny switch, from adding to multiplying, that's where all the magic happens. To really see what I'm talking about, let's put exponential growth side by side with something you probably already know pretty well, linear growth. All right, check this out. We've got two tables here from our source. The one on the left, y is going 2, 4, 6, 8, and on the right, it's going 4, 8, 16, 32. At first glance, they might seem kind of similar, but the way they're growing is fundamentally different. Can you spot it? And there it is. The table on the left is linear. You're just adding 2 every single time. It's predictable. It's like walking at a nice, steady pace. But the table on the right, that's exponential. You're multiplying by 2. The steps get bigger and bigger and bigger. It's like going from a walk to a jog to an all-out sprint.
So here's the bottom line, the main takeaway. Linear is all about adding, and that gives you a straight line. Exponential is all about multiplying, and that gives you a curve that just shoots for the stars. Okay, so we get the what. Now let's dive into the how. What's the actual engine that powers this crazy growth? Well, it all boils down to one simple little formula.
This might not look like much, but this little equation is the key that unlocks the whole thing. Every single piece of it has a really important job to do. Let's break it down.
Okay, so think of A as your starting line. It's where you begin. B is your growth factor. That's the number you're multiplying by each time. And X, that's just how many times you take that step. So A is where you start, B is how fast you're leaping, and X is how many leaps you take. Simple as that. Now, let's put this into practice with an example from our source. We want to find the value of y when x equals 3. So, first step, we just swap the x for a 3. Then, you got to handle the exponent first. So 5 to the power of 3 is 125. And finally, you multiply by that starting value, which is negative 2. And that gives us negative 250. See? Just a few quick steps. So we've got the concept, we've got the formula, but what does this kind of explosive growth actually look like? Let's take a look at it on a graph. The graph tells the story at a glance. If your growth factor, that b value, is bigger than 1, you get that classic, iconic upward curve of exponential growth. But if b is between 0 and 1, the curve flips. It starts high and then drops fast, flattening out over time. We call that exponential decay. But how do we even get that curve in the first place? Well, it all starts with the numbers. Let's take this example from our source and actually see how the formula creates the picture, one step at a time. First thing we do is make a little table. We just pick a few numbers for x and plug them into our formula. So if x is 0, y is 4. If x is 1, y is 8. If x is 2, y is 16. Do you see the pattern? It's multiplying by 2 every single time. And when you take those points we just found and you put them on a graph, you get this, that perfect classic J-shaped curve. That right there is the visual signature of exponential growth. It's totally unmistakable. Okay, so that's the math. But you're probably sitting there thinking, why should I care about any of this? Well, it turns out this is probably one of the most important mathematical ideas you will ever come across.
Seriously, this pattern is literally all around us. It's how compound interest makes your money grow. It's how populations expand. It's the reason a goofy video or a dangerous virus can spread like wildfire. Honestly, understanding exponential growth is like having a superpower for understanding how the world works.
And here's a really wild, mind-bending idea from our source. When something decays exponentially, like radioactive material, it gets smaller and smaller, and it gets closer and closer to zero, but it never ever actually reaches it. It's like a journey towards nothing that lasts forever.
Once you learn to spot this pattern, you're going to start seeing it everywhere, in the news, in finance, in nature, in technology. So my question for you is this: now that you know what you're looking for, where are you going to see exponential growth next?